Class, in this video here, we're going to be discussing how a torque wrench works. That's the objective. We're going to start a how-to series. So this one is specifically about torque wrenches. There's different types of torque wrenches. Before I get into showing you the actual torque wrenches in different scenarios, I want to discuss about how a torque wrench works and what's the concept behind that. Okay, so here we have an example of a few wheel nuts, and we're going to discuss about tightening. Now, I'm going to be using this very long ratchet here, okay guys, and I'm going to apply it to this this wheel nuts over here, okay? So right now remember, this is just a concept. Nothing's perfect here. This is, ideally, we're going to have this horizontal for our lesson. Okay, so this is horizontal. I took the time to measure the distance from the center of this ratchet to where 1 foot would be. So this ratchet's clearly longer than a foot. When we're tightening nuts and bolts, a lot of our specifications we get are in foot-pounds. This is American. You can have Newton meters, which would be a metric system, and sometimes less than foot-pounds would be inch-pounds. Nevertheless, I'm going to be referring to, in this video, a lot of the imperial system, which is foot-pounds. I'm going to be discussing that a lot. If your torque wrench only measures in Newton meters, or if your torque wrench only measures in inch-pounds, then you're going to have to convert it. Nevertheless, okay, so if I was going to tighten this wheel nut, I'm going to apply pressure to the handle of the ratchet, and I'm going to put some force down to turn it. When we're tightening nuts and bolts, when we're tightening any fastener, every fastener has a suggested limit as to how tight the fastener should be. And you get that information from the service manual. We use the Mitchell or Pro Demand. Anyway, so I measured out one foot over here. And if I wanted to tighten that fastener, that bolt, to 10 foot-pounds, which would be how much twisting force I apply to the fastener, then I would take the time to measure out what 1 foot is and add a 10-pound weight to that, and I place it right on that 1 foot position, and now that ratchet and weight is applying 10 foot-pounds of twisting force to that fastener. Okay? Now, if I needed to increase that twisting force or the torque to that fastener, then I can do one of two things. I could add more weight, or I could increase the leverage that I'm using, the different type of wrench. So I don't have a longer ratchet than this, so what I can do is I can add a different weight. So here I have an additional 10 pounds. So what I'm going to do is I'm going to move this weight so that the two weights are on the 1 foot spot right in the middle. So now I'm applying 20 foot-pounds to that fastener right there. Okay, so now what we're going to do is we're going to go over to our bench over here, and we have a tremendous amount of torque wrenches. I've gotten a few of them from other shop teachers from different schools, because this video is not just for our school, it's to be shared. Okay, what I have here, guys, is a bunch of different types of torque wrenches. There's a lot of torque wrenches on this bench. I'm going to discuss quickly. I don't want to spend a lot of time on this right now until we get to the actual spots. So what we have over here are, from here to here, we have click type torque wrenches. That's what we're going to be focusing on. Here at our school, we have a lot of click type torque wrenches. Another thing that we have, and these type of click type torque wrenches, there's different types. Most of these, all of these from here to here, they're what we call a micrometer click type torque wrench, okay? This click type torque wrench here is a little bit different. This is the only one I have. This is my personal one from home. This is called a split beam click type torque wrench, and the split beam click type torque wrench has an advantage over these others and a disadvantage. The advantage of this type of torque wrench is we do not need to relieve the pressure that we set the torque wrench to. When we use these micrometer click type torque wrenches, I'm going to show you in my example that when we're setting it to the desired torque that we want, what I'm doing is I'm compressing a spring, and I have to relieve that pressure before I put it away. Whereas with this split beam, I don't have to do that. Okay, so I'm not going to be using that today, but it's a very easy torque wrench to use. Now, the accuracy of the split beam is less than the micrometer style. It's only about 1 or 2% difference, but nevertheless, it is different. It might be okay for doing wheels or suspension stuff, but when we get to internal engine stuff, we really have to buy a higher quality torque wrench. This torque wrench here is a digital torque wrench. This is the very high-end torque wrench, and we're gonna show that in our video how we use that. Similar to the click type torque wrench, but it makes beeping noises and it has some lights, and we set the desired torque we want digitally with a variety of buttons, and there's a display here, like let's say a digital watch. Okay, these type of torque wrenches here are probably the lowest quality that we have. These are beam style torque wrenches. These are okay for rotational shafts. They're very low quality though, I gotta say. This is like your Walmart, Canadian Tire, Home Depot, the lowest quality torque wrench, okay? These lose accuracy over time simply because in the tool room, a lot of students like to move the beam and they think it's a toy, but you're bending the rod, and you can see here it's not even zeroed anymore. It's not starting at zero. So this is no longer accurate. But I'm gonna show you how to use it because there are scenarios where this makes sense. Over here, what we have over here, these two, this one's digital. These are torque angle meters, and what this does is it measures the degree of rotation we're tightening a bolt to, and in some situations like cylinder heads or crankshafts, main bearing caps, when you're torquing a bolt, you set it to a specific amount. The manufacturer will say 20 or 30 foot-pounds with an additional 75 degrees or an additional 90 degrees, and we need such a tool to measure the angle at which we tighten it. This is not a torque wrench, but these are torque extensions, and they're specifically designed to be used with the power tool, and I'll discuss how to use that in a different video. But the accuracy on this is extremely low. It's plus or minus 10%, which is fine for wheels, but you're gonna have to do your final tightening with a click type torque wrench or one of these digital ones, something a lot more accurate, okay? Now this torque wrench over here is similar to these beam style, but much higher accuracy. You can see here, my dial is covered by a piece of plastic. I can't touch it. So I'm gonna show you how to use this later on, but this one is a higher accuracy than these beam style ones. But we'll talk about that in a minute. So what I'm gonna be doing here on this setup here is I'm gonna be putting a drain plug back in, and I'm going to be using this torque wrench, this click type torque wrench, and I'm going to be showing how to do that. Now, before we go ahead and put that on, what you don't want to do, guys, and I'm going to discuss this in another video on how to use a ratchet more, is you don't want to put your fastener on your tool and throw it into the product and then start turning it. You're going to cross thread the bolt. You got to take every nut and bolt and you got to thread them in by hand. Now, also I want to take it in consideration the condition of the bolt. We'll talk about that in another video more, but this one has a rubber washer there, so we have to consider that the rubber washer cannot be over tightened, it'll split. So this has a specific tightness of around 10 foot-pounds. You can see I snugged that down by hand all the way. Now I'm going to set my torque wrench, and before I set my torque wrench, this is a micrometer style torque wrench. I hope that we can see all these numbers here on the video here. Now, what I do is before I get started, I pull this out of the tool room or out of my toolbox, and one thing I want to indicate is the lowest setting, and this over here is 30. And this one is an inch-pound torque wrench, and 30 is the lowest setting on the micrometer scale there. And I want to make sure 0 is lined up on the main reading line. Now, what I want to do is I want to set this to 10 foot-pounds. That's what I want to tighten this bolt to. So since this is in inch-pounds, I need to multiply 10 foot-pounds by how many inches are in a foot. There's 12 inches in a foot, so I need 120 inch-pounds. And how I do that is I got to take the handle and I got to rotate it up towards 120. Now, as you can see on my torque wrench, there is no 120. So on the left side, I have numbers starting with 50, 90, 130. On the right side, I have 30, 70, 110, 150. There's no 120. So what I'm going to do is I'm going to aim for 110. So how I get there is I'm going to support the top half of the ratchet, and I'm going to pull down the locking mechanism. There's usually some sort of locking mechanism, and then I can rotate the handle in such a manner that I bring it up to 110, the 0 lined up on the main reading line. Let me get there, and then I'll let the camera focus. And there it is. And you see how that locking mechanism clicked in place. The 0 is lined up with the lower line of 110. I don't know if we can see that in the video, but you're going to have to show your instructor this before you start using the torque wrench. Every time before you start using your torque wrenches, guys, you set it to the desired torque. Have your teacher see you've set it to the desired torque, before you start using it. Okay, so I've set it to 110, but I need 120. So how am I going to get there is I take the handle and I add 10 to that. So now I'm 110 plus 10 on the handle, and that's 120 inch-pounds, which is 10 foot-pounds. Okay, so I'm going to take this torque wrench, which is set to 120 inch-pounds. I'm going to apply it to my bolt, and this is called a click-type torque wrench. And on the click-type torque wrench, I'm going to turn it. It's like a ratchet, and I'm going to keep on tightening until this portion here makes an audible click, and it's going to move like somebody who's double jointed. I'm not quite double jointed on my thumb, but it'll move oddly in this section. You have to pay attention. So as I turn it, pay attention. Are we zooming in here? Hopefully we can. There you go. And you can see right there, I've hit 120 inch-pounds. There's nothing stopping me from keeping on turning. I'm going to demonstrate that. And by doing that, I'm damaging the gasket underneath there. And you can see I can still turn. The torque wrench is not limiting me to turn the bolt more. It just gives me an audible sound and a visual to let me know I've reached the set torque. Now, I'm finished with this. I'm going to call my teacher over, have your teacher show your teacher that you've set it to 120 inch-pounds in this case. Before I put this torque wrench away, and I know you can't see that in the video, is I can feel this as I use it. I'm compressing a spring inside this micrometer style torque wrench. I have to relieve that tension. So what I'm going to do is I'm going to pull back the handle. Remember at the beginning of the video, at the beginning of this portion of the video, I took a second, a mental note, indicating what was the lowest setting. In this case, it was 30. So I'm going to lower that to the lowest setting. In this case, it was 30 inch-pounds on this torque wrench. Every torque wrench is different. I'm going to set it to the lower line of 30, and we can see that in the video. I'm going to show that to my teacher, and now I'm going to put it away in the tool room. Now, what I want to do, the same bolt, is I want to use this digital torque wrench. Okay, so I'm going to be using a different torque wrench to tighten the same bolt. I just want to show you how that works. So what I'm going to do is I'm going to loosen that bolt. Okay, so it's loose. Now remember, every time you want to use a tighten another bolt, it's always in by hand first. Okay. Now I'm going to use this digital torque wrench, and this is a really nice little tool here. So this digital torque wrench, guys, I have the power button here, and I got to set it to the desired amount. Remember, we want 10 foot-pounds. Right now it's sitting at 35. That was a previous use. So I'm going to use the down arrow until we can get to the 10 foot-pounds. Oop, not 9, 10, there you go. I'm going to grab the same socket that we used before, put it on the end of my ratchet, and this one here, there's a button, and the button is held to release the socket and to install the socket. If the button is not held, it's hard to pull off. They do that on purpose, okay? All right, so here we go. So I'm going to tighten this one. This one is not a click type torque wrench like the other one. This one doesn't have a double jointed section here. The head portion is still like a ratchet. We're going to be paying attention to the screen. There's going to be lights, and it's going to make an audible beeping sound. Now, the neat thing about these digital torque wrenches is as you get close to the desired set torque, the lights will turn yellow, then green, and then red if you go too far. Okay, so here we go. I'm applying torque. Remember, I got to put my hand in the right spot on the handle here. I'm going to talk about that in a minute. So you can see I'm getting closer, getting closer. There we go. I'm at 10 foot-pounds. Now, let me go a little bit further and see what happens. It's vibrating and it's turning red, indicating, hey, you've gone too far. You've over-tightened it. And this one even goes as far as telling me how much more I'm putting in. So I saw 12 there. So I applied too much torque to that fastener. Again, I've damaged the gasket there. I know what damaged the gasket. It's just for demonstration purposes. Before this engine goes into service, I'm going to have to throw in a new gasket. Okay? Okay, back to the micrometer click type torque wrench. One thing I forgot to mention when I was using it is that these handles, as you can see here, there's a line there. That's not decorative. The purpose for that handle, even this one here, it even has section with these lines here. The purpose for that, if you go back to the beginning of the video, I mentioned how we're talking about foot-pounds of torque. So a foot and how much pounds we're applying to it. The objective is that I'm putting the middle of my hand directly on that handle, applying the suggested amount of torque to the center or to the 1 foot section. Now, it might be a little bit longer, it might be a little shorter because I have the exact same torque wrench here that's clearly longer, right? It's clearly over 1 foot long, but nevertheless the handle is the same. And the objective is on these torque wrenches, they're designed so that you apply your hand pressure directly at that section there. You're not applying here, because if I set it to 10 foot-pounds, this is not the desired area where I can apply my 10 pounds of pressure. Okay, and when I set it to 10 foot-pounds, guys, I'm literally applying body pressure to it, and it actually is 10 pounds of pressure. That's what it ends up being. If I have a longer ratchet, I would have to, so let's hypothetically say this ratchet or this torque wrench is 2 feet long, and I need to apply 10 foot-pounds, I would hypothetically only have to apply 5 pounds of pressure to it. Now, because I'm not taking the time to measure this, and I'm not taking the time to measure the amount of body weight I'm putting on the torque wrench, we're going to set it to the desired amount and it'll click when I get there, provided that I'm applying pressure to the handle specifically. Okay, guys? So that's the key important thing that I see a lot of students doing, is they put their hands wherever they want to. No, you have to apply your pressure to the base. Now in this case here, this has got a little lip here. I'm going to apply the back half of my hand. My finger is right up against it so that I'm right at the handle, and then I can apply the pressure. In this section of the video, I'm going to be tightening this starter motor down to the engine block. And the reason why I'm discussing this one is because this one has 2 fasteners to hold it down, okay? So which makes the job a little bit different. Okay, so again, we're going to start the nuts and bolts always by hand, okay? I'm going to thread both of them in by hand. And I got to make sure that, I'm threaded all the way in. Now, depending on your instructor, they may ask you to thread the nut and bolt all the way down, which I'm going to do in this example, all the way down by hand. And see, I'm wiggling the starter as I'm doing that. And if I allow it to sag, pressure down, I can't turn that. But if I wiggle it, you can see I can still move that bolt a little more. So that's the trick, right? It's wiggling as I'm going in there, because this is not centered. So it's very heavy on the back side here, right? So I'm just going to wiggle it a little bit as I'm turning. That'll get me all the way down. Okay, now, the suggested torque for these fasteners are 35 foot-pounds of torque, okay? And I have 2 bolts here. Now, right now, both bolts are only hand tight. And what I want to do is I want to torque both of them, ideally at the same time, to 35 foot-pounds of torque. But I don't have a tool that can do that. I only have 1 torque wrench, hypothetically. Okay, so I'm going to use a different torque wrench in this example. This is our snap-on. This is here from our school, our snap-on, and it's a foot-pound torque wrench. Whereas this one here is the same drive. They're both 3/8, but this one's an inch-pound torque wrench. And this one does not achieve, it cannot achieve 35 foot-pounds. It can't go that high, okay? So I'm not going to use that torque wrench there. I'm going to use the same principle, is I'm going to tighten these 2 fasteners, except they're different size bolts. And here, let me grab the different socket there. And actually, I'm going to use an extension. So I'm going to use an extension. I'll discuss that in a second. Okay, now, when tightening, before I even use the torque wrench, I'm going to use the ratchet as an example. When tightening, so in this case here, I'm going to use an extension, which you're allowed. You're allowed to use an extension. And I'm going to use a socket. And I have a couple of different sockets here. And I have a fixed socket. So this one is, this is 9/16 this size here, or 14 millimeter. This is 9/16. This is a 9/16 flex socket. Now, a flex socket does just that. It flexes, or a universal socket. I'm going to be applying my pressure on an angle. Torque wrenches don't work that way. Okay? You can use your torque wrench on an angle. You can, but the accuracy goes out the window. Okay? So the objective here is leverage. Okay? So if I'm applying pressure to this, twisting this bolt, this fastener, I am in line, I'm dead straight. If I'm at an angle, now I'm applying additional leverage. I'm no longer in the accurate range, So this is inaccurate way to tighten or torque nuts and bolts, okay? So I have to use a fixed socket, and you can use an extension, because an extension, all it does is it's still in line with the nut and bolt. And the only reason I'm using an extension is because this one fastener here, as you can see, I'm right up against the oil pan on this engine, And it's a lot easier for me to be up here away from the oil pan than to be fighting the oil pan and to be on an angle, and I might round the head of the bolt. Okay, so remember I said 35 foot-pounds? Now, here's the thing. When you have multiple items, multiple fasteners to bolt one item in, the objective is to tighten them in a pattern or in steps. So step one, you got to thread it in by hand. Then I take into consideration what the overall torque is. In this case, we have 35 foot-pounds just as torque. 35 foot-pounds, the number 35, or if I were to say something weighs 35 pounds, that's not a heavy number, that's not a large number. We're going to take that number and we're going to divide it by 2, 3, or sometimes 4, depending on how big the number is. The larger the number, the more times you have to divide. You can ask your teacher what amount of times they want you to divide that. At 35 foot-pounds, I'm going to divide that by 2, so I'm going to get a 17.5. Now, the torque wrench might not do decimals, but that's fine because we don't have to get the exact 17.5 foot-pounds of torque. We can do 17 or 18, so it's nominal. Divide it in half and get a nominal number, something around, okay? So what I want to do is I want to tighten this bolt to 17 or 18 foot-pounds, then this bolt to 17 or 18 foot-pounds, then I can come back to the first one and tighten it to the suggested 35, and then this one over here to 35 as well. I don't want to tighten one bolt to 35 foot-pounds and the other bolt is still hand tight only. What I'm going to do is I can warp the product I'm tightening. In this case, it's a pretty heavy piece of metal, in this case aluminum, tightened to a cast iron, so not a huge deal, but in a situation where there's a gasket involved, and I'll show you that in the next section, that could be a big deal. Okay, so let's start with this digital torque wrench. We're going to set this to 17. Okay, so I'm going to tighten this. Here we go. We're going to see the lights here. I'm going to tighten it. Now, I'm holding it in line. Make sure I'm in line. So that's my left hand. I'm right-handed. So my right hand is on the handle. We talked about that already. And my left hand is supporting the head of the ratchet. And I'm pushing down at the same time, right? Getting close. There's the first light. Keep on going. Second, third. There we am. 17 foot-pounds. I'm going to go to this one. 17 foot-pounds. Now, I know you can't see that in the video, but the display is actually indicating the number as well, which this is pretty obvious when you're doing it. So now I'm going to apply the 35, the desired amount. Now again, you're showing your instructor before you use the torque wrench, hey sir, hey miss, I've set it to 17. Hey sir, hey miss, I've set it to 35. Okay, so this is important. I can really feel the pressure here. Oh, the whole engine wants to rotate. There you go, that's 35. Next one. You might have to have your partner hold the engine because the whole thing wants to rotate. It's just on an engine stand. There we go. So 35. Okay, now I'm going to loosen that off and I'm going to use the micrometer click type torque wrench. I know every school has different types of torque wrenches, and I just want to make sure that I'm indicating the two different types. Okay, so I'm just going to loosen it a little bit. Okay, there we go. So that's loosened. I'm going to set my torque wrench to 17 foot-pounds. The lowest number, again, these type, you have to, the lowest number is 5 on this one, really low. And the zero's lined up with the main reading line of 5. I don't know if you can see that in the video, but nevertheless, you can see that in person. So I'm going to, in this case here, this locking mechanism has to be pulled up, whereas the other locking mechanism had to be pulled down. So every manufacturer does something a little different. So this one I have to pull it up. And I'm going to rotate the handle. That's 5 so far. And once around got me to 10. One more time around has got me to 15. One more time around to get me to 20, too much. So I'm going to add an additional 2 on the handle. So now I have lined up at 15 and then just a little bit higher than 15 with 2 lined up. So that's 17 foot-pounds of torque. Apply my extension with my socket on there. Okay, so here we go, 17 foot-pounds. And you heard the audible sound. And if you zoom in here, you can see here that this thing's gonna click. Pause. No. Okay, we're gonna keep on shooting there. I feel the tension now, it's getting there. Here we go, we're getting close. There we go. And you can see this is like a double joint right here. All right, that's it, that's 17. Now I'm gonna set this to 35. Again, I'm gonna show my teacher that it was torqued to 17. And then I'm gonna show my teacher that I have set it to 35. Okay, there's 35. Again, I'm supporting the head of the ratchet. I'm pushing down towards the bolt with my left hand. I'm right-handed. I put my hand covering the entire handle here, okay? And I'm gonna turn, we're gonna look for the click, and I'm gonna feel it. Did you hear that, how much louder that was? And this is one thing I wanna point out, is that the lower the number you set the torque wrench to, the click is quieter. The higher the number you set the torque wrench to, the click will be louder. So here we go. Let's go to 35 on the next one. There we go. So that's set at 35. Pause. Okay, so I just finished torquing the starter motor, and it was set at 35. I have to relieve the tension. If you remember at the beginning of this section, this torque wrench was set to 5. That was the lowest number. I have to relieve the tension of the torque wrench to the minimum number. We call it zeroing the torque wrench, even though it doesn't go to 0. And there we go, I'm set at 5 foot-pounds is the lowest setting that this torque wrench can do. I can take this torque wrench and I can put it in the tool room, put it in my toolbox. It's no longer under tension. One thing that you'll notice when you start using these type of torque wrenches, as you're turning it to get to the desired amount, the handle becomes harder and harder to rotate. That's because I'm compressing a spring, and now I've relieved the spring, I can feel the tension relieving as I loosen it. Okay, so on this engine here, this is a cylinder head. We're going to be discussing tightening the cylinder head bolts. And you can see here on this one, we have 8 cylinder head bolts. So we have 4 on the bottom, 4 on the top. Now, like before, I have to do this in steps. Actually, this cylinder head, the manufacturer specifically recommends 3 different steps, okay? So the first step is going to be 15 foot-pounds. The second step is going to be some oddball 27 foot-pounds, and then we have to add an additional 90 degrees of rotation. So I'm going to show you how to do that, okay? So first things first is I'm going to tighten everything by hand first. And again, I'm not using any leverage. I don't want to get my hands right into this tiny little sections of the engine. So I threw the bolts in. I have a gasket underneath these bolts, a cylinder head gasket, okay? And I'm just gonna snug all these bolts in by hand first. And you're gonna get your partners to help you with this. This is not always a one-person job, right? It's great to work in pairs in this situation. Hopefully you guys are working in a situation where your partners are always looking at or thinking about what the next step is, so that you guys can increase the speed at which you do some of these tasks, right? It's kind of like a soccer team, you know? You have the defense, you have the offense, you have the goalie, you have the center, and everybody's doing their part, right? You're not standing around looking at your phone. There's never a situation where there's time for that. You're reading the next step. You're thinking, okay, maybe I got to get this tool. Maybe I can start cleaning up. Maybe I can start answering these questions, right? So that's what we want to be doing here. Okay, now they're all down. I'm going to torque these to the suggested 15 foot-pounds that the manufacturer recommends initially. Now, if you notice, my extension here is a 1/2 inch drive. Now, the 1/2 inch torque wrench that I have, the lowest setting is 30 foot-pounds. So I can't use this extension in this socket. So I got to move to a 3/8 drive, and because I have a 3/8 torque wrench here set to 15 foot-pounds, and again, I'm going to set it to 15 foot-pounds, and I'm going to show my teacher that I've set it to 15 foot-pounds before I use it. Now, when tightening these bolts, okay guys, what's really important, because there's 8 bolts here, there's 4 on the bottom, 4 on the top, you have to start with the center. If you ever learned how to iron, my aunt taught me how to iron a shirt or a pair of pants, is you always start in the center and you want to iron out the wrinkles. So you got to keep the gasket in mind that's underneath the cylinder head. If I start tightening on this section here and I just go up and down and work my way across, I'm going to create a wave in the gasket and it's going to wrinkle at the end. I got to start in the center. Okay, in this case I'm going to start on the top. I'm going to set it to the desired 15. We're going to watch and listen for the click. I feel some pressure. There it is. It's really, really quiet, right? Now I'm going to go to the bottom. Keeping in mind my hand is in the center of the handle when I'm tightening, okay guys? Not on the bottom, not in the middle. It's got to be in the center, okay? So I did the top one, I did the bottom one. Now I'm going to move over to the left. Bottom one, I'm going to stay right there. Click, clickety clickers. Go to the top there. Over to the top on the next one. So I'm working in the center, working my way out. Now I'm going to go to the outside one over here. On the outside one over here. Okay, you're going to show your teacher that. Now I'm going to set it to the next setting, according to the manufacturer, which isn't that much higher than what it was before. So I'm not going to have that much of a turn. There we go. So it feels a little tighter, right? But it's not too tight still. And that's where the next type of torque wrench I'm going to be using is called a torque angle meter. And I'm going to be measuring the additional degrees of rotation. Okay, so now we're going to be looking at this torque angle meter, and there's two different types. I'm going to show you this mechanical one first. So I'm going to half inch because my my torque angle meter is at ½ inch. I'm going to place that on there. I'm going to place my torque angle meter there. Now there's this alligator clip. I need to position this at a stationary portion in the engine. So it can be anywhere really, as long as it's stationary, okay? Now what I'm going to do is I'm going to zero my gauge here. And you can see there's a bunch of degrees of rotation. I'm going to zero it. Okay. Then I'm going to grab my ratchet. And this doesn't need to be a torque wrench. Just a regular ratchet will do, or even a Johnson bar, right? So I'm going to place that on there. Okay, and I'm going to put tension on there. You can see how as soon as I put tension, it went to 10 degrees. So I'm going to change that just to zero that again. I really got to spend the time making sure this is accurate. So I need 90 degrees of rotation. Okay, here we go. One swoop, in one quick swoop, doesn't have to be quick, sorry, in one continuous movement, I want to get to 90 degrees. So this is measuring my angle, degrees of rotation. You can have your partner watch it and he'll tell you or she'll tell you when to stop, but I need to do it in one rotation. I can't do it and reposition my body, okay? So this engine is going to want to rotate, so I'm going to use my foot on the engine stand here, and here we go, 90 degrees is what I want. There, 90 degrees. Okay, you can see there I stopped at the 90 degree mark. So that bolt had the original 15 foot-pounds, and I think it went to 22 or 27, I don't remember the exact number, and then it told me an additional 90 degrees. These bolts are what you call torque to yield bolts. They're one-time use bolts. After I've torqued to yield these bolts, I've stretched them, and they're acting like a spring, compressing the gasket down against the cylinder block, and it's a one-time use. So if I need to remove these cylinder head bolts, they're garbage. They're one-time use. So now I would go ahead and I'd reposition this on the next bolt. Okay, so I got to zero that again. We'll show you one more time. Okay, and 90 degree rotation. So again, putting my foot on the engine stand there so it doesn't rotate on me. I got my hand on there on the handle, and I'm going to put some good effort into it. Here we go. 90 degrees. This is a digital torque angle meter. This one's a little bit different. So this one clips on the extension. I'm using a regular extension and a ratchet, and I still need 90 degrees. So I've set it, I dialed it in, I turned on the machine, I dialed it into 90 degrees. Before I rotate, I'm gonna press the on button. Oops. Press the on button here. And that's 0, here we go. You can see the numbers going around. When I get to 90, it'll tell me. There we go, 90 degrees. So this one's a digital one, a little bit different than our mechanical one, but same idea. I got that 90 degree rotation. Okay, these type of torque wrenches are specifically designed for rotational force. How much rotational force does it take to rotate a specific shaft? This one here is a beam style. I don't like using this that much because a lot of students tend to mess around with the dial because it's exposed. If it gets dropped, it's a big issue. On this one here, it's covered up, so pretty easy. Okay, so I'm going to show you on this crankshaft here, on this engine, I'm going to try and rotate that. I want to know how much rotational force it takes to rotate that crankshaft. Did I tighten down the bolts correctly? Is there any sort of internal damage? And that's where this type of thing can show me that. Okay, so I'm going to place that on my front of my crankshaft there. I'm going to zero this. I can even use a dial. This has a neat little dial. It tells me how much effort I've put in. Okay, here we go. I'm going to just rotate it. You can see I'm rotating, rotating, rotating. It's not turning yet. There you go. And maxed out at 50 inch-pounds according to this gauge here, which is kind of neat. Is that accurate? Is that within spec? Now, these ones, you don't have to set them to anything. You literally just watch the gauge as you're rotating. Now, you can see here on the crankshaft, I'm rotating the crankshaft, right? Okay, I just want to know how much rotational effort. That's what these dial style or beam style torque wrenches work. One thing I want to talk about is these torque wrenches are precision measuring tools. We don't want to drop them. They lose their calibration. If we take this type of torque wrench, the micrometer torque wrench, and we loosen the torque lower than the lowest setting, so we zero it and we really reef it down, what we're doing is we're changing the tension on the spring, and that torque wrench is no longer accurate. We have to send it out to get calibrated. This torque wrench here, it needs a battery, so you're gonna have to throw a battery in there maybe once a year or whatnot, but you don't want to drop them. These are precision measuring tools. They're very expensive on top of that, so we got to be very careful with these type of tools.